Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. I'd love to introduce Brendan Birds, the Corporate Vice President of Azure Cloud Native and Management Platform. Brendan, can you walk us through what happened? How did we respond? What did we learn? We'd love to know more.
Sure. So in West Europe, first, I think it's worth understanding the ARM architecture a little bit. ARM is the front door to Azure, and all of the requests from our command line tools or our portal, really any API interactions with Azure to create resources go through what we call front doors. And those front doors are in all of our different Azure regions. They take the HTTP requests and they process it, authorization, and all of that, and pass it on. Now, the way you end up in one of those front doors is through the network, and you go to the region that happens to be closest to you. And so if you happen to be in the general geographic region around West Europe at the time of this incident, your requests, either from the command line tooling or from the portal, went into the West Europe region. Now, unfortunately, in the West Europe region, we had just rolled out about 24 hours previous to the incident starting. We had rolled out a new release of the Azure Resource Manager front doors. We do this roughly every week. Unbeknownst to us, that release contained new code that had a lock contention issue. And unfortunately, this lock contention issue didn't manifest even when we rolled it out to West Europe until a workload, a different service in Azure that was performing requests against our front doors, lit up and started processing 24 hours after our release. It was sort of a 24-hour sync job. It started sending us a very specific request that happened to make heavy usage of the place where the lock contention had been introduced. This caused a bunch of spin locking to happen inside of our process, which caused CPU starvation. And at its worst, we saw about a 50% degradation in successful requests coming to West Europe. So that means that anybody in the general geographic area around the West Europe data center would have seen issues connecting to Azure, creating VMs, visualizing their infrastructure in Azure, even if those resources perhaps were in a different region, because of the nature of the way that the ARM front doors receive traffic from around the world. And in a few instances, actually, we also saw people in other parts of the world who happened to be VPN'd into regions near our West Europe data center seeing impact. Now, the root cause of this was the lock contention that I mentioned, but it was actually quite challenging to detect because over the span of 20 minutes, we saw this region go from healthy to very unhealthy. When we see this kind of CPU saturation, the first thing that the DRIs are trained to do is to scale up. We assume that there's some increase in load that is causing more problems, but even as we scaled up, those resources became contended, and through a bunch of retry storms, both within ARM as well as within the clients that were calling ARM, the load just continued to build in this region. And actually, we took an action that we didn't actually think would work at the time, but was to roll back to the previous build. This was sort of out of a sense of, it couldn't possibly hurt to roll back to the previous build, even though because the new build had been healthy in West Europe for 24 hours, we didn't actually believe that it was necessarily a problem with the new build. At the same time, we were investigating the traffic patterns. We saw the log contention in our monitoring, and we saw a particular traffic pattern that was tied to a particular internal service and actually a particular IP address. And we managed to find those people, reduce the client load, and actually also block that IP address in our own front doors. And the combination of those efforts, the rollback to remove the code bug, and then blocking the traffic that was causing the problem in the first place, eventually got us back to a world where reliability was back up to the 5 nines that we normally deliver in West Europe. Now, at the same time, you might be thinking, like, why didn't we drain the region? And it's an interesting question because this is actually a case of a poison request. And so if we had taken the West Europe region out of rotation, that traffic would have simply gone to a different region. and would have harmed that region instead. And so the judgment call that was made at the time was that though West Europe was clearly very heavily impacted, draining out of that region wouldn't have actually helped solve the problem.
So. Super, thank you very much. You mentioned earlier that your engineers or your DRI scaled out, and I'm assuming yourself, your engineers, and many of our audience will know what a lock contention is. But could you explain it so my parents could understand lock contention?
Sure. So on modern processors and in modern computers, there's multiple cores, right? Which means that the code that you write runs simultaneously. Two different user requests, for example, may be being processed at exactly the same time on two different cores within that computer. But there's certain areas in memory where you want to ensure that only one thread of execution, only one set of instructions is happening. One of the classic examples of this is like a bank transaction, where you want to ensure that when I'm going to transfer money, the withdrawal from one account and the deposit in the other account happen together in an atomic way without any other transactions happening in the middle. That's an example of where we might lock and introduce a lock that basically blocks all those other parallel threads of execution. And lock contention is when multiple processes are trying to acquire the same lock. And so you could imagine if I have 30 or 60 cores in a computer and I have 30 or 60 requests being processed in parallel, if they all want to hold on to this lock, I've suddenly got a 30x reduction in the number of requests that I can process.
That's a really helpful way to understand it. Now, a question here about monitoring. You were talking about how we track down the IP address and were able to identify it. But would we say that this was caught by monitoring or not? It sounds like there were some improvements that would have helped us to discover it earlier. What does that look like?
Well, I think it was caught by monitoring in the sense that our availability dropped, right? And so we very clearly knew that there was a problem. But I think that we could have done a better job helping the DRI understand where the problem was coming from. In particular, that gap between the deployment of the binary and the poison traffic starting was confusing because normally we would assume that if it's a problem in the binary that we rolled out, it would start immediately when we did the rollout of the binary. And I think better monitoring to understand that relationship between a change in a request pattern and the availability problems manifesting would have helped the DRI have a better insight quickly into the cause of the problem and therefore the solution to the problem as well.
Magic. Brendan, I have a question. We mentioned we deployed, you do your deployments typically one a week. It was about 24 or something hours where you were into the deployment, and then everything was going well until West Europe. So West Europe showed a hiccup, and you mentioned that there was one client and so on. How do you manage your service where you may have anomalies in a region versus testing, organic traffic patterns through monitoring and customer traffic? How do you manage a service with small anomalies here and there that can create these hiccups?
Yeah, it's worth saying actually we were much further than 24 hours into our release. We were in West Europe, deployed in West Europe for 24 hours before the problem manifested itself. And I think this is another important lesson, which is that whenever you're developing these safe deployment practices, they're based on the assumption that every place you go to, every region that you deploy to, looks the same, has the same kind of traffic, has the same, I've seen incidents in the past where even something like a different character set because you're in Asia versus in West Europe may cause a problem, right? So I think we have to do a better job ensuring that our synthetic testing that we do in Canary and in pre-integration testing is representative of all of the different workloads that we see, and obviously this is one where we can improve our coverage of our synthetic tests.
Right, that's helpful to understand. Now, you talked a little bit about the rollback that helped with the mitigation. We've had customers asking us on different incidents before, how do you decide whether to roll back, whether to roll forward? Is it possible that in doing the rollback, we might break something else that's taken a dependency on the latest release? Could you talk us through a little bit kind of how we make decisions like that?
Well, I think the goal that we have is that rollback is a seamless and straightforward and safe thing to do every time. That's certainly the goal within ARM, and I think generally speaking, that's been the case with ARM. It has relatively little state stored internally, and most of its state is outside of the process, which makes that rollback easier. I think that sometimes we choose to roll forward if we've identified, we may have a release that has actually fixed a number of bugs. And we don't actually want to regress. Rolling back involves actually regressing a number of bugs. And so we don't want to regress. So, and if the fix that we have is small and tactical, we may choose to patch and roll forward. But I think in general, we try and roll back as a first course.
Super. Brendan, I have one last question. You joined us previously on the Azure Incident Retrospective, and you did mention you had long-term plans, and I'll check my notes, for load balancing ARM calls. Would an investment like this help de-risk a situation that happened in West Europe?
Yeah, I don't think it's necessarily about the load balancing as much as the traffic control generally, right? So we were lucky in some sense in that the IP address for this particular set of requests was a single IP address because it was a single process running in a single VM. That could have been coming from a replicated set of things. It could have been coming from dynamic IP addresses. It would have been much harder, given what we currently have in the system, to block those requests. And so I think there is ongoing repair work in terms of being able to effectively control requests based on a small set of characteristics and potentially even throttle down significantly specific classes of requests that are causing problems while, sort of noisy neighbors, if you will, while we're in the process of investigating and taking action to restore the service. And so there's ongoing investments within the ARM team. And it is related to a degree to that same sort of like being able to spread traffic around.
Super. Great to understand. Now, I often will turn the tables on my co-host here, since Sammy, you run the incident communications team. How did we do in terms of being able to communicate updates to customers and partners who were impacted by this ARM issue?
So in the beginning, we had auto communications go out. This goes out through our system that we call Brain. Brain will auto communicate to impacted subscriptions within 15 minutes. And that worked very well. So as customers were trying to create or delete or scale out virtual machines, they do this using ARM, and they ran into problems. And so they would be communicated to pretty quickly. That happened for a while. Now, over 70% of our services and our scenarios over 70% of our outages get communications via Brain, which is great. There are some services and scenarios that don't. And when those services started reporting impact, we were sending communications to those customers. As we saw impact grow, and because ARM is a service that every service uses to create and delete and rename resources, we realized that impact was going to be big, and that any service that was calling ARM was going to run into problems. That's when we decided to communicate publicly on our status page so that all customers could see, but we continued to send targeted comms through Azure Service Health at the same time in parallel. But most of the communications here was done via our automated comms and Brain.
That's helpful to understand, and actually really good kind of differentiation between when we use the status page and when we use Azure Service Health within the portal there. If you go and look on the status page, you're not seeing everything. We only use that for a few specific scenarios, and we've got that documented with a link at the top. Generally speaking, people should be looking in Service Health in the portal. That's great to understand. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.
Thanks.